Okay, so I'm going to go through these pretty quickly because there are a lot of them. The reaction of baking soda and vinegar to produce carbon dioxide. Remember from your chalk lab, guys, that CO2 is a gas and therefore it doesn't form a precipitate, which is solid. It actually forms a gas. Okay. The next one, when balancing chemical reaction, you may alter the coefficients but not the subscripts. That's what I've been telling you for a very long time. Once you have made your compound by crossing your charges, leave it alone and only put coefficients to then balance. Okay, so that was true. The following equation is balanced. It wasn't. Remember, you balance C's and H's and O's, so that was fine. I had H4, so I needed to put a 2 there, and now I'm balanced, so that was false. Li, K plus, and NH4 compounds are soluble. That's true. This next one, however, the only exceptions, the only times that these guys are going to be insoluble is with Ag, Hg, and Pb, and so this is false. They're mostly soluble. 6, we remove the spectator ions from the full ionic equation to form the net ionic good. True. Spectator ion is one that does not actively participate in a chemical reaction. That is true. They spectate, they watch, but they're not actually involved. Okay? When the equation, this, is balanced, so for any of these questions, guys, where I'm asking just for one of the coefficients, balance the whole thing. So I've got N2 here, so I'm going to put a 2 here. Now I've got 6 O's, so I'm going to put a 3 there, and it's 6. So the coefficient for H was a 3. Again, for this one, even though it doesn't look like it, guys, this is a combustion because I've got my hydrocarbon here and oxygen. So the order honestly doesn't matter at all, so don't let that bother you. But what I need to do is balance my C's and my H's and my O's, just like always. So I've got 5 C's here, so I need to put a 5 here. I've got 12 H's here, so I'm going to put a 6 here to make that 12. And then that's 10. And that's 6, so that's 16. So I need to put an 8 in front here to make that 16. Okay. 10, what are the coefficients? So what do I want to do? Well, I got 1 mg here, 1 mg here, I'm fine. I have 2 Cl's here, I've got 1 here, so I put a 2 here, and then I've got 2 H's, 2 H's. So remember, if there's nothing here, imagine they're 1s, but you don't actually write that they're 1s. Okay? Not that I'm calling anyone out or anything. So this is going to be 2, 1, 1, 1. An aqueous solution is, this answer right here, guys, is wrong. This should be D. Okay, so I'll write that in. That should be D. And the reason why is because an aqueous solution, all you need to know really is that an aqueous solution, you took water and you added a compound to it. It's not molecular, it's actually ionic all the time. But we didn't get into that really. We will, I promise. But all you need to know, to make an aqueous solution, take water, dissolve a solid compound into it, and there you go. Okay. Number 12, which of the following is insoluble? You have to look at your table, guys. And so if you didn't get this right, you're not comfortable with your table. So I would come in and get help. Okay. 13, the compound sodium sulfate is soluble in water. So when it dissolves, guys, you've got Na plus and you've got SO4 2 minus. Right? You got 2 NAs and 1 SO4 2 minus. So if you look, this is the only one, A is the only one that matches up. If you had 2 Na plus here, that would be fine. All right, because that looks like that. All right, 14. If you had an aqueous mixture that contained Ag plus, K plus, and Pb2 plus, how many different solids would precipitate? Okay, so I'm going to look at Cl and say, okay, with how many of these guys will it form a precipitate? Meaning, will it be insoluble? So Ag plus and Cl, that is insoluble, so that will form our solid. K and Cl, that is soluble, so that won't count. Pb and Cl, that is insoluble. So you just have to look at your table, guys, which I'll give to you. So that's 2. The answer is 2. In writing a chemical reaction for precipitation reaction, which abbreviation of the physical state must appear so in order for a precipitate to form, guys, you've got to have a solid. Okay. 16, a precipitate is expected to be formed when an aqueous solution of sodium sulfate is added to an aqueous solution of, okay. So this is the hardest problem I could give you, and I definitely will give it to you on your test. Okay, so you need to make sure you understand it. Here, what you're doing is you're trying to predict what the products will be, and specifically whether the products will be soluble or insoluble. So for example, I did the answer one here, but you should do it for all of them. I'm going to combine Na and Cl. Now, you don't have to perfectly cross charges. Just think about Na and Cl together. Will they form a soluble or insoluble compound? And NaCl is soluble. So that doesn't work because we want to form a precipitate. What about Ba and SO4? Well, Ba and SO4 will actually be insoluble, so that forms a precipitate. Okay, let's try the other ones just to see how I got it. Na and Cl will form together. NaCl is soluble, so that won't work. Fe and SO4 will combine together. Those are both soluble, so that won't work. NaCl is soluble. KSO4 is soluble. NaCl, so you see how I'm just, doing outies and then innies. Na and Cl, nope, soluble. MgSO4, nope, soluble. So that's how I got D for my answer. All right. 17. Considering the following precipitation reaction, which compound will not form ions, meaning which one is the spectator ions. So you don't even have to do the whole problem, guys. If you want to, you can. But recognizing the fact that this is going to be insoluble because it makes a precipitate, a solid, and this is soluble, which means this is going to be in its ions. All of these are in ions, which means the K's are going to cross each other out. The NO3s are going to cross each other out. So the one that actually stays is PbI2. So A. 18. Considering the following precipitation reaction, which would not be present in the net ionic. So again, and I feel like that's the same question. Yes, same question. Sorry. Okay, I'm not going to, well, sort of, not really. Which ions would not be? So this is the compound that's formed, and so Pb and I would be in the net ionic, meaning that K and NO3 would not be in the net ionic equation. So it's a very similar problem. Which is the correct net ionic equation for this, which we just went through? It's Pb plus, so we got Pb plus, I have two i's, but you can't write it like this, remember. I've got to write it like this. So Pb2 plus 2i minus gives me PbI2. Awesome. 20. This is a combustion reaction. You got a hydrocarbon and oxygen, making CO2 and H2O. And this, guys, take two separate things, combine them together. That's a synthesis reaction. So A. Double replacement. Which one is it? So K and NO3 together, Ag and Cl. This is double replacement. Na and Cl, Ba and SO4 together, that's double replacement. H and OH to make H2O, and Na and SO4, that is double replacement as well. So the answer is D, all of them. All right, for balancing, I got two NO3s here, so I'm going to put a 2 here. I got 2 Ag, so I'm going to put a 2 there. Now I'm balanced. B is already balanced. C, my issue is that I have 5 O's here, so I need to put a 5 here. Then I've got 5 CA's, so I put a 5 here, but now I've got 5 S's, but I've got 5 S's right there. So I'm balanced. D is also balanced already. This one is really hard, guys. What I would recommend doing, if you see that you're adding 2 plus 1 to get 3, which is odd, it's going to be a nightmare. So I would recommend putting a 2 in front here. Now I've got 2 zincs, so I got a 2 here. And I've got S there, so I need 2 S's there, so I need to put a 2 in front of this. And then I've got a total of 4 plus 2 O's, so that's a total of 6. And now I'm balanced. Okay. For this one, the next one, guys, I messed up in writing the problem, so I'm going to redo it with you. I want to make this into a 6. Oops. Okay. So if we make that into a 6, let's actually go and rebalance it now. All right. So I need a 4 here because remember I balanced C's and H's and O's. So 4 there. I'm going to put a 3 here, so it's H2. Now let's figure out how many O's I have. So I've got 6 O's there. I've got 8 O's there, so that's a total of 4. Oops, not 6. Sorry, 3 O's. Wow, my brain is not working today. 3 O's there. I've got 8 O's there, so it's a total of 11. So this is going to have to be 5.5, because 5.5 times 2 is 11. Then what you want to do is multiply everything by 2. So that's going to become 2. That's going to be 11. That's going to be 8, because 4 times 2 is 8. And that's going to be 6. Okay? All right, next one. You've got to just identify them, guys. Honestly, you should know this by this point. Okay? Ca goes in, kicks out H to make CaCl2 and H2, so single replacement. 2 things combined together to make 1. Synthesis. 1 thing breaking apart. Decomposition. you got a total do-si-do of partners. Ag becomes partners with PO4, K with NO3, so it's double replacement. If you have a hydrocarbon plus oxygen, that'll give you CO2 and H2O. That's always combustion. Again, do-si-doing of partners, this time with OH and H to make water. That's double replacement. This is decomposition, breaking down. And so just check your answers, guys. I've pretty much explained all of them. Okay, so you're just having to identify synthesis, decomposition, double replacement. So check, pause it, because I'm moving on. Alrighty, so you're going to have a bunch of these guys. I know you love them. I'm taking water and a non-metal oxide, so it's 1C. I need to make an acid. Remember, I balance as I go. So H2, then my non-metal, which is carbon, plus my oxygen, and I've got 3 oxygens total, so H2CO3. This is O2B, so I'm going to combine my metal with oxygen, so Na2O, plus my other product is CO2, and I'm already balanced. This is single replacement, guys, because Li is going to kick out Al. Li is higher than Al, so it can do that. Al will be here, plus Li needs to combine with O. Charge of Li is +1, charge of O is 2-, so I cross my charges and I get Li2O. And this is it balanced. Okay, so double check me, but I think I'm right. D is double replacement. Na is going to bind with Cl, Pb with CO3. Pb in this problem, guys, has a +4 charge, so I'm going to first cross Na and Cl, which are both 1, so NaCl, plus CO3 is 2-, Pb is 4, so this would be a 2, this would be a 4, so they reduce to just 2, and then I balanced it. Okay. Here, this is single replacement. Remember, I told you to write H2O for single replacement as HOH, so HOH. So what Ag is going to do is it's going to come in, and it is going to, actually, I don't think this actually happened. So I'm going to teach this. I believe if you look at your chart, guys, I think this is no reaction. So I'm sorry, no reaction. And R. But I'm going to really quickly just explain it since I'm already here. I can't type. Okay, so Ag kicks out H if it could. H will be by itself. So Ag will bind with OH, because OH is what's left, and H will be by itself as H2. But that doesn't actually happen because Ag is lower on the activity series than H is. Okay. Here, combination, simple. Na is +1, O is 2-, so you cross your charges. There you go. Here it's 2D. You're going to make a metal oxide just like, I think I just did that one above. But cross Li and O, and you get your answer. And your other product is H2O. Notice that this is the exact opposite of... Nope, haven't done it yet. Sorry. Okay, this one is kind of tricky. It is a combustion reaction. Remember, C's then H's then O's. So other thing, really quickly. I messed up. H should be H10, not H5. So correct that. And then balance with me. So I've got 6 C's, so I put a 6 here. I've got 10 H's, so I'm going to put a 5 here. Okay, and then as far as O's are concerned, I've got 5 O's here. I've got 12 O's here, so a total of 17. So 17 halves, okay, or 8.5 is fine, and then multiply everything by 2. So 2, 17, 12, and 10. This is 1B. I need to make a base, so RB crossed with OH. And that's it. Then for this one, this is single replacement. Again, Mg is going to kick out H just like above. Where'd that one go? Oh, I erased it. Just like this one, but this one actually wasn't supposed to happen. Whoops. Okay, so I'm going to combine Mg and OH. So across my charges, I get Mg in parentheses OH2 plus, because H was kicked out, H2 since it's diatomic. This one, guys, I should have my metal with HCO3. HCO3, if you look at your chart, has a charge of -1. So when I cross my charges, Ba2 goes down there, 1 goes there, so that's my answer. Okay, and this is actually not balanced. I messed up. There should be a 2 right there as well. Okay, then you should be balanced. Yep. All right, here this is double replacement, Al with Cl and Na with O, and then balance it. So those are my answers. Here, guys, Fe, the charge of Fe is 3. That doesn't tell you how many Fe's you have. So Fe kicks out Cu, so it becomes FeNO3 3 plus Cu, because Cu is kicked out. Make sure to balance. Ignore the 3 here, because this is the charge, not how many Fe's there are. Here, this is just a double replacement. Zinc and PO4 are going to combine together, and H and Cl combine together. Okay, so you're crossing charges. Zinc is 2 plus, PO4 is 3 minus, H is +1, Cl is -1, and then balance. This is a synthesis reaction. Remember, this is one of the exceptions where the negative goes before the positive, but I still cross my charges. If you wrote H3N, guys, that's fine. This guy's crossing H and O, +1 -2. You should get that. This is another simple combustion reaction. Remember, if I have to have 4.5, which I did in this problem, because this was supposed to be a 6, not a 5. Sorry. Multiply everything by 2. Here, this is a synthesis reaction. Okay. This is you're breaking down into your nonmetal oxide and water. Remember, it's balanced as you go. So write water first, and then your nonmetal, so N, and oxygen, however many else you need, because you're balancing as you go, so a 2. For here, guys, this should be Li plus O2 because it's a simple decomposition, then balance, and it's O2 because that's a diatomic. Here, just water because this is a 1B, but make sure it's balanced, which it is. And then here, it's a 2D, so it's a base, so I need to cross my metal, which is Pb, which has a 2 charge because O is -2, this is +2. Cross your charges and you get that. Don't forget parentheses, okay? For this, guys, I'm going to explain it in the next video because I'm out of time.